So in this lesson, we are going to compute exponential growth or decay when we have a percentage change. And it's building on what we ended the last class with. So we're going to compute this or complete this table where we put $1,000 in the bank and it earns 2% compounded, which is a very important word, annually. So at the end of every year, my balance goes up. I figure my interest on the 1,020, so my interest goes up. So now I have a new balance, a new amount of interest. You'll see your interest is increasing a little bit more than 40 cents each year. Again, these are not large numbers, so you can't really see the impact as much. So now the question is, if you use the basic interest equals principal times rate times time, would you get the same balance? In other words, if you did 1,000 times 2% times 5, you'd only get 1,100 as opposed to the 110408. Not, excuse me, a significant difference, but it's because it's a small balance of 1,000 and it's a small or low interest rate of 2%. But the reason it doesn't is because the formula that we use, this formula, does not compute interest on the interest earned. And that's what the table above does. This concept of compounding is an exponential growth or decay concept. So similarly to what we did in class, our growth formula is y equals a times 1 plus r to the t power. R is greater than 1. Decay, or decline, the only difference is I'm subtracting, and the other difference is r has to be between 0 and 1. It can't be greater than 1, then I'll have a negative number. And then again, as we said, a is the initial amount. Oh, nice to spell correctly. R is my rate, okay? And you write it as a decimal, as we'll see in a moment. And t is time. And the key thing is your time and your rate have to be on the same period. In other words, if my rate is per year, my time has to be years, or vice versa. So now I could simply figure out my balance after 5 years by using the formula. $1,000 times 1.02. Why is it 1.02? It's the 2% for 5 years, and I get my 110408. Much easier than doing a complete table. All right. So now I have my patient care costs. How would I model that? 968. It's increasing times 1.04 to the t power. Why is it t? I don't know the time. Okay. Now, if I'm going in year 2010, that means I have gone 15 years. So now I would figure out what the cost is after 15 years. And that amount is $1743.31. Okay? My community has 4,512 students, and it's growing 2.5%. So my formula, T, what will the population be in 3 years? So when you do that, you get a decimal, and I've seen it done both ways, a rounding up and down. Okay? I've usually rounded down on this. but I understand the concept of which way you would round. Okay, when will the population reach 5,000? So this is what we're doing. Remember from the other day, we put our general equation, this equation, into y equals. We go to our table and we see it's 5 years. Okay. So now we have Malik buying the car. So we're going to compute this table. I'm just going to fill out the table. It's depreciating, which means it's going down. This is very similar to the table on the front page. If you know how to use Excel, you can set up formulas and this will be done for you instantaneously. I'm just going to fill out the columns. It takes me less time. And then these are just my balances. Now, how would I write my formula for this? My formula would be my value, V of t, value after time, is equal to my beginning balance times 0.85. How did I get 0.85? It's going down 15% a year. What's its value in 5 years? Well, we did it above, but now using our shortcut, we see that we'll get the 5657 that we have above. And then after 7 years, it's 408736. Okay. All right, now we have our population. So our formula, P of t equals 60 or 600,000 times 1.05 to the t. It's growing. The other one, F of t, is 700,000 plus 10,000 t. The first one is an exponential. The second one is a linear function. At what point does it exceed? Again, we would be using our calculator to do this. We would put both of these into our calculator and see that it would be sometime during 2015. Okay? If Oz doubled its food supply, would shortages still take place? Yes, sometime during 2031. And for E, it would be sometime during 2034. Again, how you would do this is you would put each equation into your y equals and call up your table and look at the values that are on the table to answer the questions for you.